Tyler. One more round of applause for Tyler Matheson. Did he do a wonderful job today? Thank you. Well, good afternoon, ladies and gentlemen. My name is Art Benjamin, and I am a mathemagician. What that means is I combine my loves of math and magic to do something I call mathemagics. But before I go any further, I've got a quick question for the audience. By any chance, did anyone happen to bring with them this afternoon a calculator? If you happen to have one, perhaps on your phone, and if you're comfortable using it, raise your hand. I need a few people to help me out with their calculators. I see one person there, one, and we go two, and perhaps one more, three. Will the three of you bring out your calculators? Join me up here on stage, and let's give these volunteers a nice round of applause. Thank you very much. Thank you for that. Right there will be great. Yeah. Cut right up on stage. One more round of applause for our brave volunteers. Thank you. Right this way. And I'm not going to ask you to do anything hard. Now, since I have not had the chance to work with your calculators, I need to, oh, we got four people, even better. Since I haven't had the chance to work with their calculators, I need to make sure they are all working properly. Would somebody get us started by giving us a two-digit number? Sir, how about a two-digit number? 26. And another two-digit number, please. 34. Multiply 26 times 34. Make sure you get 884 exactly, or the calculators are not working. Do all of you get 884? 880. Oh, you're making a phone call there. 884. Let's give them a round of applause. That's got to unlock the calculator there. Fantastic. Now, I notice that took some of us a little time to get the answer, and that's okay. I'll give you a shortcut for multiplying even faster. There's something called the square of a number, which most of you know is taking a number and multiplying it by itself. For instance, 5 squared would be 25. 6 squared would be 36. 73 squared would be something bigger, right? Now, most of these calculators actually have little shortcuts for squaring, and if you know them, you should use them. Like on this one, if you want to square 5, you press 5, then times, and then equals, and that will give you the square. Some of yours have little x squared buttons that'll do it even faster. What I'm going to try and do now is to square in my head 4 two-digit numbers faster than they can do on their calculators, even using the shortcut method. What I'll ask is 4 people, how about here in the first row, 1, 2, 3, 4, each yell out a two-digit number, and if you would square the first number, the second, the third, and the fourth one, I will try and race you to the answer. So quickly, a two-digit number, please. 32 squared, okay, next. 81 squared, next. What was that? 13 squared, and one more. 46. Would you call out your answers, please?
1,024.
1,024. 6,561. 169. And finally?
2,160.
Give them a round of applause. Thank you. Let me try to take this one step further. I'm going to try to square some three-digit numbers this time. I won't even write these down. I'll just call them out as they're called out to me. Anyone I point to, anyone at all, call out a three-digit number. Anyone on our panel, verify the answer. If I get the answer right, give me a thumbs up or show everyone the answer. If I make a mistake, let me know and I'll try and fix it. A three-digit number, anyone? What was that again? 227 squared is 51,529. 51529, great. Another three-digit number, please, three-digit number. 355 is 126,025. 126025, great. Another three-digit number, sir. 999 is 998,001. 998001. How about one more three-digit number? Go ahead. Well, 748 is, oh, that's a hard one, 559,504. Thank you very much. Whew. Let me try to take this one step further. I'm going to try to square a 4-digit number this time. Now, I'm not going to beat you to the answer on this one, I promise, but I will try to get the answer right. To make this a little bit more random, how about we use 4 people in the second row this time? 1, 2, 3, 4. Each call out a single digit. That will be the 4-digit number that I'll use. 8. 9. What was that? 5. 7. 8, 9, 5, 7. This will take me a little bit of time. Whoa, so bear with me. 80 million. 8, 9, 1, 4. 227,849. Good. Thank you very much. Now, I would attempt to square a 5-digit number, and I can, but unfortunately, some calculators don't go that high. Wouldn't want to embarrass them. Although I think most of yours do, and I will talk to you about that later. But in the meanwhile, let me conclude the first part of my show by trying something even trickier. Let's take the first big number on the board here, 6561. Would you each enter 6561 on your calculator? And instead of squaring it this time, I'd like you to take that number and multiply it by any 3-digit number that you'd like. But don't tell me what you're multiplying by. Just multiply it by any random 3-digit number. So you should have as an answer either a 6-digit or probably a 7-digit number. Do each of you have a 7-digit number by chance? 7 digits? 6 digits? And 7, I think? Is there any possible way that I could know what 6 or 7-digit numbers they have? Say no. Good. Then I shall attempt. Ted, you're still working on your cat. You're giving me a little concern there. You have a 7-digit answer at this point? 6 digits. Well, then you've made a mistake. Okay. Start again. Take 6561 times any 3-digit number. Okay? What I'm going to ask each of them to do is to call out for me any 6 of their 7 digits. And Ted, do you have 7 digits now? Or Bill, in your case, call out 5 of your 6 digits in any order you'd like. 1 digit at a time, I shall try and determine the digit you've left out. So starting with your 7-digit number, call out any 6 of them, please. I'll repeat them so the audience can hear. 8, 8, 4, 0, 2, 7. Did you leave out the number 7?
I did leave out
Good.
the number 7.
Good, that's 1. You've got a 7-digit number. Call out any 6 of yours loud and clear. 0, 4, 5. Did you say 4? 0, 4, 5, 4. 0, 5. Oh, I'm having a little trouble with this one. Don't forget your number. I'll get back to you. Bill, you've got a 6-digit number. Call out 5 of your 6 in any order. 36127. I believe you left out the number 8. Great. Ted, the odds of me getting all 4 of these by pure guessing would be 1 in 10,000. Ted, call out 6 of your 7 in any order. 5, 6, 3. 133. Did you leave out the number 6? Good. I was worried about that one. Tony, I've got one troublemaker left here, and it's you. Do me a favor, if you would. Concentrate on the digit you left out. It doesn't do any good, I know. It just looks dramatic here. And yet, I seem to be getting a lot of nothing. You didn't leave out a 0, did you? No, because it seemed like you're thinking of nothing. All right, concentrate hard. I'm going to get it this time. You left out the number 9. Exactly. And let's give all 4 of these people a nice round of applause. Thank you very much. Well done. All right. For my next number, most audiences don't get that. I've got another question for the audience. By any chance, does anyone here happen to know the day of the week that they were actually born on? If you think you know your actual birthday and you're willing to share it, raise your hand. Okay, starting with you, sir. What year, if I may, what year was it? 1939. And what month? May what? 12th. Was that a Friday? Yes, good. Somebody else. Who else? Yes, please. Shout it out. What year? 56 and 36. Okay, and the month? August what? Was that 25th? Was that a Tuesday? Excellent. Somebody else? One more person here. Yes, sir. What year? 47. And the month? February what? 26. Was that a Wednesday? Yes. Anyone here who does not know their day of week but always wanted to find out? James, okay, you got your hand up right away. I'll let you be. Now, I'll tell you, now, of course, if you don't know what it is, I could, just make up an answer and you'd probably believe me. But luckily, as Tyler said, there are apps for everything these days. I'll ask you to help me out once again. All you have to do is scroll to the right year, and the rest is pretty simple.
Got it.
So, James, what year, if I may? I go back to 1932. Okay, let me think about that for a second. July 26th, I believe, is a Tuesday. Let's see if the app agrees with me. Thank you. I'll tell you what, Highlight, as long as you have the app with you, let's try something even trickier. The app will go as far into the past as 1600 and as far into the future as the year 10,000. Oh, do you want to go into the past or into the future?
Into the future.
Into the future, of course. That's what this conference is all about. All right, well, how to scroll as far as you'd like, all the way, don't go past 10,000. The app won't let you do that. And when you find a year that you're happy with, let me know. What year would you like to do? Oh, you got a particular year in mind, I can tell. All right, what year would you like? 4,304. Okay, let me think about that. All right, and a month. Beth, give us a month, please. August. August what? 12th. Will that be a Friday?
It sure will be a Friday.
Yes, and it'll be cloudy, I think. Thank you very much. Thank you. By the way, if anyone else wants to find out their day of the week, see me after the show. I will be hanging out at my table in that corner. Randy actually gave me a table to hang out on after the show. I'll be more than happy to tell you. Folks, the last thing I'm going to do for you today, because as a professor of mathematics, my full-time job is professor of mathematics at Harvey Mudd College in Claremont, California. And I wouldn't be doing my job today if I didn't give you a little bit of a sense as to what's actually going on in my head. Now, if you want all the details, I have some books and DVDs that Randy said I could offer at my table. I'll have them in the back corner. See me after the show if you're interested. But I'm going to right now not so much explain, but let you enter my mind so you can hear what actually is going in my head while I do a giant calculation. Let's create this time a 5-digit number, something I mentioned that I would try earlier. But to make my job more interesting for you as well as for me, I will do this problem thinking out loud. Let's get the third row this time. You have 5 people, each call out a single digit. That will be my 5-digit number. 7, 3, 8, 4, 6. Oh boy, this is not going to be an easy one. 73,846 squared. Yuck. Let me explain to you how I'm going to attempt this problem. I'm going to break the problem down into 3 parts. I'll do 73,000 squared plus 846 squared plus 73,000 times 846 times 2. That's the hard part. Add all those numbers together and with any luck arrive at the answer. Now let me recap. Thank you. While I explain something else. As I do this last calculation, you will hear certain words, not just numbers, but actual words enter the calculation. Let me explain what that is. This is a phonetic code that I use that allows me to convert numbers into words. I store them as words, later on retrieve them as numbers. I know it sounds complicated. It's not. I just don't want you to think you're seeing something out of Rain Man here. There's definitely a method to my madness. One last instruction for my judges with calculators. Now, who's got an answer? Raise their hand. A few of you. Good. You should have a 10-digit number beginning with 5, ending with 6. In between, I don't know yet. There's a 50% chance that I'll make a mistake somewhere in the middle. If I do, don't tell me what the mistake is. Just say you're close or something, and I'll try and figure it out, which can be pretty entertaining in itself. If, however, I am right, whatever you do, don't keep it to yourselves. Make sure everybody knows that I got the answer right, because this is my big finish, okay? So without any more stalling, here we go. I'll start the problem in the middle with 73 times 846. 73 times 846, how am I going to do that? I'll take 73 times 84 first. 73 times 84 is 7 times 12. 73 times 7 is 511. Times 12 is 6,132. That's 61,320 plus 438 is 61,758. 61,758, double that to get 123,516. 123,516, that seems right. I'm checking. That seems right. I'll go on. 123,516 becomes denim loadage. Denim loadage or lettuce is 123,516. Haven't said any part of my answer yet, but I'm about to. Denim loadage. Okay. Finally, we do 73 squared, which is 5,329. So I can say 5 billion. Take the 329, add that to denim. 329. I see a carry coming, so I'm going to say 330. Add that to 123. To get 453 million. Lettuce. Okay. Finally, we do 846 squared. That's 800 times 892 plus 46 squared. That's 713,600 plus 2,116 is 715,716. Cottage, if I need it. Cottage. Take the 715, add that to lettuce to get 231,716. Yes. Good. Thank you all very much. I hope you enjoyed Mathemagics. I'm Arthur Benjamin. Thank you.